Hi, I'm Quincas, I'm a synth DIY guy. Welcome to today's video, which is installment number 3 on our 4-part series about the Euclidean Back in Black series of modules developed by Rebel Technology and distributed via Befaco. The build part of this video, as with the other two, will be actually at the end. We're going to start with the demo this time. So let's get to it. We've already looked at Stoichia, that's the correct pronunciation, I think. So I pronounced it wrong in the other video. Anyway, Stoichia is a dual Euclidean sequencer, and we've already looked at Klasmata as well, but I'm not using it today. I'm just using 2 channels of Stoichia into Phoreo, right? And I didn't know how to pronounce this, but I've already looked at a video by Martin Klang, the designer, and he pronounces this Phoreo. So that's how I'm going to pronounce it as well. And basically Phoreo is a trigger and gate processor of sorts. So what it can do is it can modulate the pulse width of the incoming signal. So if you can turn a trigger into a pulse or a pulse into a trigger, and you can continuously vary that pulse width by either using the knob or the CV input over here. Now the second function is multiply. So this will multiply the incoming clock by up to 16 times, and that's determined by the knob over here as well as the CV input. All of the CV inputs have attenuators, which are these 3 knobs on the right side over here, right? And the third function is repetition, which is kind of a burst generator. It'll generate a number of repetitions based on the multiplication. So the repetition knob determines how many repetitions, so how many triggers will be in the burst, and the multiplication determines how fast or which clock division multiplication you're using for that repetition. Now the inputs are all normaled to each other, so that means if you're using the same clock for all 3 functions, you only need to plug it into the pulse width modulation input up here, and automatically it's getting cascaded down through multiplication and repetition. Right? The outputs are dedicated per function, and so are the CV inputs, right? The pulse width also gets carried out throughout the outputs. So when you change the pulse width, even if you're using one of the other outputs, they will also reflect the width of the pulse as it's set by the PWM knob and or CV input. So without further ado, let's turn on my clock here so we can hear what the pattern is doing. There's a kick drum. Dong, 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 dong. And the clock is just going, it's traveling around in the stereo field a little bit, varying in timbre slightly, but this is what's going through Phoreo right now. Right, this is kind of an FM voice I made with my second Generate 3 module over here. Dun, duck, 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 duck. Tuck, 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 tuck. Right, so the kick and let's call this our tambourine are channels of Stoichia, while our steady kind of hi-hat click thing is just a clock, straight up clock. So now right now we are using the the pulse width output over here. So if I manually turn up my pulse width, right, it extends that pulse width, and I've set the envelope to be an ASR. That's important, right? If you just use an attack decay envelope, the length of the gate's not going to affect anything. So you do need to have a sustained stage in order for this to be even audible, right? Now one cool thing I can do is modulate that. So I can take an output from orbit 3, which is my chaos oscillator, and stick it into the mod input over here. Right, so now we're chaotically modulating the length of the note. Right, I can make it more extreme by turning up the attenuator for that, or make it more subtle. chaos a little faster, so it'll be a little bit more chaotic. Very cool, right? So let's pull that out for a second. We'll leave our pulse short for now. And now we're going to swap the cable, the output here, which is triggering the envelope for that, let's call it our melodic voice, even though it's just a rhythmic melody. I'm going to move it down one row to the multiply section, right? So for now, you don't hear anything because our multiply knob is all the way down. As I turn it up, you see how it's starting to divide the clock differently, right? Up to a really fast roll. Very cool. Let's turn down the number of triggers on this pattern so we can hear. Cool, right? And again, this is also modulatable via CV. And there we have it. I'm using the Orbit 3 again. This time to modulate the multiply parameter. Cool, right? I can still modulate the pulse width. See? Very interesting. Okay, now let's move down to the repetition. Right, and this is, let's make the pattern with less fill now. And okay, so now with the multiply parameter, we determine how quick the repetitions will be, and with the repetition knob, determines how many repetitions, right? So it can be just a few, like 3 or more, and it can be super fast or slower, right? And again, pulse width affected, and we can modulate either or both parameters, right? So now modulating multiply, let's bring that down so it can be affected by the incoming CV. Very interesting generative rhythms now, right? As we get more complex, more chaotic, it becomes less predictable. Now I can also modulate the repetition parameter. So now the bursts are shorter or longer, depending on how many repetitions. Right? I can modulate both parameters as well if I want to. So now not only the length, as in of the burst, as in the number of repetitions, but also the density of the burst, right? I guess you could call it that. And by the way, we've been using a single signal cascading through the 3 outputs here, the three sections, but you can use them separately, right? As you plug something into any of these inputs, you break the normalization, so you can actually use all three functions simultaneously for different signals. Modulate the pulse width on one, multiply another, and then create repetitions with the other. Just remembering, of course, the multiplication parameter will affect the repetition as well. As I've been doing with all of these, we can play around with audio rate modulation as well. Let's have a look at audio rate. Right, so I'm gonna plug this straight over here now, and we're gonna use our clock in audio rate. So here's the pulse width here now. Let's remove the modulation now and just use it manually. Let's get the multiply here. Very cool. Right, let's listen to the repetition one. Why don't we modulate our clock, which is the contour 1 here. I'll modulate that with the chaos. Or maybe with the sequencer instead. Here. There we go. Alright. Now here we have pulse width, multiplication, and it repeats. Oh wow. Badass. Let's modulate something chaotically here to multiply. And the repetition parameter. Oh my god, this is crazy. I think this is the most fun of these yet. At least in audio rate. Very cool. Super video gamey, chaotic. Modulate that pulse width too. Super fun. Yeah. Alright, I think that's it for the Phoreo. Hope you liked the video. Stay tuned for the build portion. I'm gonna watch right now. Yeah, that's it. Let's go build. Okay, let's go on with kit number 2 of the new Rebel technology pairing with Befaco. Phoreo. So we got transistors, regulator, 2 caps, ceramic caps, the resonator for the IC, 2 diodes, an electrolytic cap, 2 ICs with their sockets. To open up the build guide here, has the BOM, the bill of materials. It tells us about the resistors. The resistors are not labeled, and I don't trust my eyes with the color code, so I check them with my multimeter. So in theory, these should be the 11 1K resistors. My meter says 0.997, which is super tight. Definitely start with the low profile components, radio components that go flush to the board, right? Just bend these, don't need to be super tight about it because the spacing allows for a little leeway there. See, it's one diode, and notice I am placing the line on the diode, lining it up with the line on the PCB. That's important. Diodes are polarized. Now we can move on to the 1K resistors. I'm just gonna gently sort of fold the lead like that without too much care. So, I should probably turn this upside down. Now, where were we? R2 and R3. R3. R501 and 502. Here's 501 and 502. Next, 504. So I'm guessing that the next values will be 701, 702, and 704. You can tell by the symmetry that these are identical parts of the circuit. And the numbering corroborates that hypothesis. There we go. I'm already warming up my iron. Okay, the next batch of resistors I have here, they should be the 51Ks because that's the second most numerous bundle. So as I check them now with my meter, I'll let you know what it says. It says 51.46K. And we'll start with 102, 103, 104. 102, 103, and 104. These kits are a joy to build. They're like old school DIY. Through hole, plenty of space. Nothing fancy or weird or complicated, just straightforward. 202, 203, and 204. Again, it's another identical part of the circuit and position on the PCB corroborate. Next, 902, 903, and 904. Up here, 902, 903, and 904. So that's all of the 51Ks. Now we have 6 120K resistors. So these should be it. This is the only bundle of 6. Okay, now we have 4 10Ks. Yep, 9.969. Now these 3 groups are all of 3 values. So unless I'm gonna get fancy with reading tiny little colors, we're gonna find out what their value is by measuring. These are 100 ohm resistors because it says 99.3 ohms on my meter. These are 100K resistors. Okay, and then these have to be the 1 meg. 1.0029. Wow, they're really close. Give yourself a good length of solder to work with, a good angle to see what you're doing, and I'm using a magnifier. It's a little bit off camera. Okay, now let's turn this board around. First, I like to sort of rub my fingers over. And if anything jiggles, it's because it's not soldered. Sometimes you just don't see it. But yeah, nothing jiggled just now. So we can turn the board around, and first thing we'll do is clip the leads. Now, if any of these has too much solder, I'll clip off the excess solder. But if you do that, you have to remember to reflow everything afterwards. Because when you cut the solder, you give it a good shake that might make it less structurally reliable, a connection. Okay, let's clean up the work area a little bit, get rid of all these resistor leads. But we're done with the most tedious and time-consuming part of any build, which is the resistors. Next will be the IC sockets. I like to go in order of profile size, so the smallest to the tallest. And remember to see where the silk screen is. Here's something interesting. There's a connector underneath the IC here. There's a possibility that we should solder this on before the socket, right? If we put the socket on there, we won't have access to these anymore. So I'm going to have a quick look at the manual. And here it says resistors, diodes, and ICs. Yeah, see, it doesn't mention the header. And I didn't get a header, I don't think. The only header I got with this kit. So it's likely that these connectors are just for programming the chip. And since the chip already comes programmed, and it'll be socketed, so you can move it to a programmer if you want to, we don't need to add this header. So we're just going to ignore it, and we're going to put this socket right there, right on top of it. Now, notice there's a notch on the socket and a notch on the PCB. You'll have to line up, right? Because they'll help you make sure the ICs themselves are correctly lined up. Okay, so I just sort of like prop these up against the edge of my table and push them in. And in order to make sure that the IC sockets are really nice and straight and snug, we solder a single pin to hold it there, right? And then we push it in with your finger as you reflow that solder, and that'll snap it right into place in case it's not already. There you go. This one had a little bit of give left. Okay, now you can visually inspect and make sure that they're snug as bugs and rugs, and turn it around and finish soldering. Probably a good idea to start with the opposite corner. That way you've got you're sure that this thing is not going to move anymore. Okay, we're getting there. Let's add the two ceramic capacitors. One goes here, the other one's down here. This is the resonator that does the timing for the microprocessor. You stick it in here. Right, it looks like a capacitor slot, but has 3 holes rather than 2. Now I am doing things the old-fashioned way, meaning I'm spreading out the component legs on the bottom so that they don't fall out. This looks like the transistor, but is actually a voltage regulator. It's probably IC3. I'm gonna have a look over here, and IC3 is the 7805 voltage regulator. Okay, so this is electrolytic capacitor goes here, and where there's a white marking, it should match the white marking on the capacitor, which indicates the negative side of the capacitor. The longer leg is the positive side. Now we have a bunch of transistors, and they come in the same strip, so that means that there's the same value. I'm not even going to look at designators. I'm just going to look and make sure that the flat side of the transistor matches the flat side on the drawing on the PCB. It's starting to rain over here. Let me quickly get my dartboard out of harm's way. It's back in position. Placing these transistors where they go. It was hiding from me behind the capacitor. We can turn it around now and solder it up. I like to anchor it with something. And go. Now we can clip off these leads. Alright, so now let's quickly touch these up. Now we're going to put on the ICs. This one goes here. Make sure to line up the notches. So the notch on the chip has to match the notch on the IC socket and the PCB. Now this is new from the factory, so it's a little bit open. See, it always happens. So you need to push it a little bit against your table like that so that it's parallel. And there you go. Again, matching the notch, right? This is a particularly nasty chip. If you invert it, the power gets inverted and you just blow it to hell and possibly damage your PSU and the module in other ways, etc. So yeah, be careful with polarity. Okay, so let's start putting on the panel components. Potentiometers here. And let's have a look at the manual. I want to make sure that these are the same value. Yep, it's 6 single 10K potentiometers, so we don't have to worry about which one goes where. Now we've already learned from the other build that each one of these is going to take a nut. So I'm going to go ahead and do that preemptively because it's easier to do it. Before we even start putting things on there, let's add the power connector. It's the only thing that goes on the backside, literally. No other component goes on the backside of the PCB. That's the power connector. Now we can start putting these guys on. Start with the LEDs. Now we know that negative is square from the other build, so the long leg is positive, goes into the round hole. So my daughter is requesting her daddy-daughter time. So I'm gonna take a break after this module. Okay, we've put on all of the panel components, but we haven't soldered anything yet. Right? All of the pots have nuts on them to approximate the height to the jacks. And now we can slip the panel on and tighten the nuts. We'll start with the potentiometer nuts. Okay, let's push these LEDs through their panel holes just a little bit, because I like them like halfway between flush and totally out. And there we have it, everything. Oh, we still need to tighten the nuts for the, whatchamacallem, for the jacks. No, I'm not making nuts for dinner, honey. So we know that the Befaco uses red for outputs, right? I know that one has to be red. Let's put the blacks on these here. Eat this? No, throw it out. Thank you. Those are leads that I've cut off from these components. No, they're trash. There's too many of them, too tiny. They're not really usable for anything. I used to keep them to make bridges, but then usually when I'm building something, from this to bridge one point to another in a circuit.
Oh, I thought you meant like toy bridges.
No, I mean like if I want to connect this pin to this pin, I can make a little bridge. Oh, you know what? I think I figured it out. This whole row is outputs because we have 3 reds. Yeah, that makes sense because these are all inputs, these are all CV inputs, and these are all outputs. Now I have my tool from Befaco to tighten these up. I have so many of these Befaco tools, it's not even funny. Each kit comes with one. Okay, let's hold this down with the clamp here so it's not dancing around while I'm soldering. And go! think I'm done. Cut off these leads, put on the knobs. Okay, so now let's put on these pots, these knobs, because everything looks like, I didn't skip anything. No bridges, nothing visible. All of the pots are in their fully counterclockwise position. Now, yeah, these pots are tight. They don't have set screws, they're just held on by pressure. We need to tighten these shafts up, otherwise it's super hard to get them in. Here's the module, Rebel Technology Phoreo, something like that. These potentiometers feel really nice, they have great torque.
Yeah, it feels really nice.
Now this is not a shrouded header, so just make sure that you line up the red. Power strip, and we're ready to go test it. There's no calibration required for this module. And then we'll move on with the next kit in the queue, the Logoi. See you soon. Stay noisy.
Stay noisy.
So that's it for today. I hope you liked the video. I hope you liked the Phoreo module. And stay tuned for Logi, the 4th installment of this series, coming very, very soon to a YouTube near you. And see you soon, and stay noisy.